Now we will discuss the process of developing an ML model. Amazon ML can be used majorly for supervised learning problems, namely classification and regression. Amazon does not provide support for unsupervised machine learning algorithms such as clustering. For now, deep learning or reinforcement learning capabilities are also not available with Amazon. The idea behind keeping it simple was to solve generic problems faster and with less expertise in this domain. Also, machine learning is not a solution for all kinds of problems. It's possible to make better decisions using descriptive statistics or sometimes with basic charts as well. It's important to understand when you want to deep dive into the machine learning way. You can keep these two things in mind when you are trying to make the decision of using ML or not using ML. First being the size of your data. If you have a large data set which cannot be reviewed manually or using descriptive statistics, you will want to use machine learning. The second is if you have largely varying patterns or features in your data, it's always a good decision of picking a machine learning algorithm for your solution, which will extract different patterns and meaningful information from your data. We will now look into the general life cycle of a machine learning application. An ML application revolves around the underlying steps we are going to discuss now. The first and the most important step is identifying your problem. It's very important to understand what your core problem is. What is it that you are trying to predict, and what are the questions your model should be able to answer? For example, are you trying to predict if a particular customer is going to exit from your organization, or trying to analyze the sale of a particular product in the coming quarter? Once you have problem defined, you will be able to answer it in analytics terms, with the problem being a classification or a regression problem. When you have an answer to this question, you can pick any algorithm for classification or regression. The second step is collecting data. For a successful model building and an effective prediction, it's always recommended to have a large historical data set so that the algorithm is able to learn most of the patterns affecting decisions. Once you have that kind of data set, you need to identify which is your target variable. For example, if the person is going to buy a product or not, and then you need to identify the features or variables which influence the target variable. For example, color, cost, length of a t-shirt might influence that the person will buy the product or not. The third step is analyzing the data. Once you have your data set ready, it's a good practice to see the data distributions of the data and to identify if there are any issues with that data set, such as outliers, missing values, unidentified values, or some corrupt data. For this, you might take the help of a domain expert who can guide you with the right values for the right field. The expert will also help you to understand some anomalies which might occur in the data set. Once you have an understanding of that, you will be able to fit it in your model efficiently. You should also look into variables which have high predictive power, that is, which influence the target variable more than others. Once you have this identification, you can remove the ones not used or the variables which have low predictive power. The fourth step is data preprocessing. Once you have your data analyzed, we will use common data preprocessing steps. The first step is removing outliers, if any. The presence of outliers biases the model, hence, it's always recommended to remove them in the first go. The second step is replacing missing values and invalid data. Missing value replacement is done using measures of central tendencies such as mean, median, mode. In case you have a numerical column, you would want to substitute it with the mean of that column. In case of a Categorical column, it is advised to replace those values with median or mode. The third step is changing categorical data into numerical data, and that is done using dummies. The fourth step is merging columns or splitting if needed. This will be needed when you have a column such as date and you want to identify the person has bought that product in which quarter. So you would probably go ahead and split your date column on the basis of day, month, and year. From this, you can extract the month column, which will give you the quarter value. The fifth step is binning for numerical fields. Binning is required when you have a column such as age. Age can take any value between 1 to 100, sometimes more than that as well. To make an efficient model, you will bin your age column in ranges such as 1 to 18 could be children, 18 to 25 adults, and so on. We also do feature transformation to bring all variables within the same range of values. If you have columns which have different measurements, you can easily convert this data set into values which will range from some same level to some same level. The fifth step is splitting data. This is an important step before we start building our model. We split our data into a train and a test set. The train set is the one on which we build our model, and test set is the set on which we check the accuracy of our model. Most data scientists split their data sets starting from a 70 to 80% in training and 30 to 20% in test set. You can decide on that metric for yourself. The next step is training the model. Once the data is ready, we train our model on a machine learning algorithm. Training involves a lot of different metrics to be changed to make the model to perform to its optimum best. The learning algorithm is decided based on the type of the problem. Training parameters such as learning rate, model size, number of passes are also decided on a step by step basis. We will look more into this in the hands on session and also while we will discuss how models are trained in AML. The next step is evaluating model accuracy. The goal of a ML model is to learn patterns that generalize well for unseen data instead of just memorizing the data that it has seen during training. Once we have the model trained, it is important to check if your model is performing well on your test dataset or not. We predict the target variable using the model and then compare the results with the actual data that we have in a test dataset. There are a number of metrics used for evaluation such as F score, accuracy, ROC curve score, recall, precision, amongst others. This evaluation metric is decided by AML on the basis of algorithm that it is using for prediction. The next step is improving accuracy if you don't have the desired accuracy of your model. There are multiple ways in which accuracy can be increased. One is adding more data to read more patterns. We can also enhance features by adding more variables which are able to predict the accuracy of my model or are whose predictive values are greater than other parameters that I have. Parameter tuning is one of the ways used widely to increase accuracy. While we are trying to increase accuracy of our model, it's important that we don't overfit our data. The next step is making predictions on unseen data. Once your model is ready, you can use it for making predictions on your data. As discussed before, we can predict using batch or real time data in Amazon. The next step is retraining models. Most people are not aware of this step, but it's also a necessary step and changes from domain to domain. The model that we have built will not be able to generalize well for data that we are going to see, say, in 3 months of time or later. So, it's important that we rebuild our model on new data for it to predict well. This scenario is called population shift and is considered equally important for an ML application. For people or domains which have real time data, such as shopping websites, need to do this on a daily basis as their population changes from product to product selling. If you have a product which can be used only in winters, then you can target the population which is buying that product in winters. Similarly, for a product that needs to be sold in summers, has to have a target population which will buy that product in summer. So, this is very important that we understand our population when we are trying to model any problem. With this, we have covered the steps that makes a machine learning algorithm. We will now look into how Amazon machine learning follows all this process and what are the features available with it.